So here is the empirical rule, everyone. And 68, 95, 99.7, and 99.9%. Usually, some books wouldn't even want to talk about the last one. Okay, but in this book, I don't know why they include that percent in there, which is okay. All right, so this means that whenever you are given a data set, it can be a data set of a population, and if it is normal, then you can use the empirical rule. What does it mean by if the data set is normal, everyone? That means that when you construct a histogram, it will look like a bell, right? It will look like this. Remember, last week you learned how to construct a frequency histogram. So if it looks like this, right? Yeah, if it looks like this, yeah, you should have the bars, right? But in general, they just make it a quick sketch like this. Okay, if it is normal, then that means that it looks like a bell, right? Then in this case, you can use the empirical rule. And if it's not normal, then you cannot use this rule at all. Okay? Then you have to use other rules. So, and how do we know that this rule is correct? We know that it's correct because many researchers and scientists have collected many data sets and many data sets, and they found that. So the first case is that, hold on. A second. Let's say this is the first case. So here is the normal distribution if the data set is normal, right? So they found that if a data set is normal, then if this is the mean, you're not sure if they use the mean. Oh, they can use the mean like this. Yeah. The mean for the measure that you use to measure the center of the histogram in a normal distribution is the mean, everyone, because in a normal distribution, the mean is the same as the median, right? The median, and it's the same as the mode when the data set is normal. Okay. But when it's normal, then we're going to use the mean as the measure of central tendency. Okay, so in this case, we're going to use the mean as the central or the center of the graph. Okay? So the rule says that if you go to the right one standard deviation of the mean, and the standard deviation, the notation for the standard deviation is S of X, right? This means standard deviation. Standard deviation. You can go ahead and write this down because I think this is useful for you to review it later. Or you can just use the letters STD dot and a DEV. In the future, we're going to just use the SDV dot DEV for standard deviation so that we don't have to write out the whole words. Okay. So if you go to the right one standard deviation, and if you go to the left from the mean, okay, from the center, one standard deviation, then this value right here can be found by subtracting S of X from the mean X bar. So you can take X bar minus S of X to find this value right here, okay? And the value on the right, you can find it by adding the mean to the standard deviation, okay? So That means that the area within these two values, that means that 68% of the data values of a data set will be within those two values, within the x bar minus s of x and x bar plus s of x. 68% of the data values will be within those two values. Or in this case, you can say that within one standard deviation of the mean. This case is within one standard deviation of the mean. Okay. Make sure that you take notes for this, everyone. It just means that if you go to the left one standard deviation and go to the right one standard deviation, then 68% of the data values will be within those two values. Let's say a class has 100 people, 100 students, and that means that they're going to have 100 exam scores on one exam, right? Then that means that 68 of the exam scores will be within those two values. Okay. I'm going to give you one example. Let's say I'm going to give you the mean. Let's say this is the exam score. Then the mean means the average of the exam scores, right? Let's say the mean is 70. The average of the exam score is 70. And then the standard deviation is 5. Okay. So in this case, here I'm going to have the 70 in the middle here. So what will be the value right here? Everyone try it and type in the chat for me. The value on the left. What is the value right here? All right, I got Yuyo, Merlos, Brittany, and Sarah. All right, good job, everyone. Right, so you yeah, so you just take the x bar. X bar is the mean, right? It's given to you. I gave it to you, right? And then you minus the standard deviation 5. It's given, right? I just gave you, which is 65. Okay. And what is the value on the right here, everyone? Go ahead and type in the chat for me. All right, I got Monserrat. All right, Angela, Brittany, Merlos. All right, yeah, here, good. Yeah, that's it. So you just take the mean, which is x bar, right? So 70, and you add to the standard deviation 5, which is 75. Yeah, so that's how you got those two values. One is to the left and one is to the right. So that means that if you look at this table here, this is an example that I got from the lecture note, the guided lecture note that you did last time. This is the let's try another example. Okay, so if you look at this example here, can you guys try this first one to see what you guys get here? In this case, you don't need to look at the diagram. You guys are given the mean already and the standard deviation. Here, it's just another notation. Everyone, if you see this means that it's the mean of the population. Okay, this is the mean or the population mean. You can say that. And you read this as mu. Okay, mu is the population mean, and this is the population standard deviation. Standard deviation. Okay, you're given those values already, and now you want to try these examples for me. Start with part A. All right, so go ahead and try part A for me. So 68% range is equal to x bar plus or minus 1 s of x. So they're asking you those two values that I just showed you how to find. But those are the, but that is a different example. And this is another example. Okay. So what are those two values, everyone? One value is on the left and one value is on the right. All right, I got Vanessa here. So in this case, they don't give you the distribution and they just gave you the formula. How are you going to do it? And in the guided lecture note, you have to do this assignment. So make sure that you know how to do it. All right, so it just means that you have to add the mean, the number on the left of the distribution. You just have to take x bar minus 1s sub x. And so x bar in this case is what? It's 100, right? So in this case, it's the same. This one here is the same thing, everyone. I think they meant the same thing, but they use different notations. Yeah, so you can think of this as the x bar, okay? Yeah. So that is the mean, and then you minus the standard deviation. This one is the s of x, okay? So the s of x is 15. All right, so yeah, so the standard deviation is 15. So what is the answer, everyone? 85, right? So the number on the left is 85, okay? So what is the number on the right? Can you guys tell me? Can you calculate it and let me know? All right, so Montserrat, how about other people? Right, you will, good. Yeah, so about more answers. So that means that the number on the right, you have to take the x bar plus 1 s of x, right? So that means that it's gonna be 100. The mean is 100, okay? The mean is 100 and added to the standard deviation, which is 15. So it's gonna be 115. 115, okay? And that's how you do it. So it just means that if you have the distribution like this, and here is the mean, okay? The mean is 100, right? And if you go to the left one standard deviation, then this value right here is 85. And if you go to the right from the mean, one standard deviation, then this value right here will be 115, okay? And that means that 68% of the data values are within those two values, 85 and 115, okay? All right, now, any questions before I let you try the next one? All right, I'm gonna let you guys try the next one. And I may call on someone, so make sure that you try it. Go ahead and do part B for me. All right, Leif, thank you. So any answers here? What is the value on the left and what is the value on the right of the distribution that you're looking for in part B? All right, I got Maserat. How about other people? We will check to see if that is correct. Okay, Uriel got the same answer as Merlos and Maserat. How about other people? All right, good job, everyone. So in part B, it just means that, so I can just call this one case 2, okay? So if I draw the distribution like this, okay, and the mean is always in the middle, okay? So the mean is always in the middle. And sometimes it can be the standard, it can be the mean mu as well. It can be this notation, the mean mu, okay? So if you go to the left, 2 standard deviations. So this is 1 standard deviation, and you go to the left, another standard deviation. Then this value right here is calculated by x bar minus 2 standard deviation of the mean, okay? And that means that if you do part B, that means that you're gonna take x bar in this problem is what? X bar is 100, right? X bar is the same as the mean mu in this case. So it's gonna be 100 minus 2 times the standard deviation is 15, okay? So that means that 100 minus 30, which is 70, okay? So the number on the left is 70. It looks like 76. It should be 70. And also from the mean, if you go to the right, 2 standard deviations, so s of x and another s of x, then this value right here is found by taking x bar plus 2, no, just plus, not minus, plus 2 standard deviations. Okay, so that means that it's going to be 100 plus 2 times 15, 100 plus 30, which is 130. Okay, so those are the 2 values that you need to find. So the answer is 70 and 130. All right, so now you know what to do for the next one. All right, I'm gonna let you try part C. I'm gonna randomly call on someone. If you have the answer, you can type in the chat for me. But if I don't see the answer in the chat, then I may randomly call on someone that don't have the answer yet, just to make sure that you get it. Go ahead and try part C for me, everyone. I got Uriel already. You guys can just send the answer to me directly, even if it's wrong. That's okay. And just go ahead and call this one part B, right? Since we are labeling them A, B, C. Got Maserat. Maserat has the same answer as Gabby and Uriel. Merlos. Luis. You guys are looking for 2 numbers, everyone. One is on the left and one is on the right of the mean. Angela, all right. It looks like you guys have similar answers. All right, Luis. We'll find out which one is correct. Okay. Now we have a few different answers now. All right, let's check to see how you guys did it, okay? But it's good that you guys tried it, right? Even if you guys don't get it right away. All right, so part C, you don't have to draw the distribution always, but it's good that you draw it to visualize. I always do so that I can visualize the numbers where it should go, and it's easier for me to do the math when I do it. So here is the mean, right? The mean is the same as the mean mu. In this case, it's 100, right? It's given to you already. You can see that it's up here. Okay, it's given. Oh, I got Vanessa as well. All right, we'll find out. And it just means that for part C, everyone, if you see 3 S sub x, it just means that if you move to the left 3 standard deviations, so S sub x, S sub x, S sub x, if you move it to the left, if you see this, that means that you move to the left 3 S sub x, or you move to the right 3 S sub x, okay? You see the minus, that means that you move to the left 3 S sub x, and you see the plus, that means that you move to the right 3 S sub x. So this number here can be found by taking x bar minus 3 S sub x, right? And x bar is the mean. The mean is 100 minus 3, and S sub x is 15. It's given to you above, okay? And you can see that this is 100 minus 45. Is that right? So, which is 50 what? 55. All right. So most of you got it right. And this is the value on the left, okay? And from the mean, 100 here, or x bar, if you move to the right, 3 standard deviations. So 1 standard deviation, 2 standard deviations, and 3 standard deviations. Then this value right here, you can find it by taking x bar plus 3 S sub x, okay? Which is 100 plus 3 times 15. So 100 plus 45, 15 times 3 is 45, which is 145. All right, so those are the answers. So if you fill it in, fill them in the blanks, it's going to be 55 right here, and then 145, okay? So that's how you do it. All right, so if you look at part B, everyone, part B right here. So if I draw the lines like that, what is the percent of this area, everyone? What is the percentage of that area between the 70 and 130? Can you type in the chat for me? We're talking about part B. What percent is between or within 70 and 130? Right, I got Uriel. How about other people? Part B, what percent is within the 70 and 130? Angela? About other people, everyone? It's what is 95.5, right? Okay, so it's 95.5%, okay? And that's the rule, right? So in this case, it's the rule that is within, this is within 2 standard deviations of the mean, 2 standard deviations of the mean, everyone. So if you move to the left, 2 standard deviations, and to the right, 2 standard deviations, then 95.5% of the data values will be within those 2 values, okay? And it's the rule that you want to remember. All right, how about part C, everyone? If I draw the lines like this, This is within 3 standard deviations of the mean. Okay, so within 3 standard deviations of the mean. What is the percent of this area, everyone? You go to the left 3, you go to the right 3 standard deviations. What is the percent of that area? Or what is the area of that? All right, Montserrat. Yeah. So it's going to be the 99.7%. Okay, it's the third case, right? It's the third case that you want to remember. So if you go to the left 3, you go to the right 3 standard deviations, then that means that 99.7% of the data values in a data set will be within those 2 values. Okay, so let's say if a class has 100 exam scores, then about 99.7 of the exam scores will be within those 2 values. Okay. All right, let's just try the last one really quick. If you got those 3 cases already, then go ahead and try part D for me, everyone. This is part D. You can tell me the answer really quick in the chat. All right, I got many answers from Merlos, Brianna, you will. All right, it looks like you guys got it already, right? Yeah, so you just have to go to the back, go to the left 4 standard deviations, right? And then go to the right 4 standard deviations. So that means that you keep subtracting the previous case from 15, so it's going to be 40, right? And then you add the previous case to 15, so it's going to be 100. What, everyone? 60, right? Good. So this is case D, okay? Case D, it just means that if you, from the mean here, you go to the left, let's say I'm going to say 4 s of x, okay? And then you go to the right, 4 s of x. Then this value here is x bar minus 4 s of x. And this value right here is x bar plus 4 s of x, okay? And what is the percent of the data values that is within those 2 values? Everyone, can you type in the chat for me? What is the percent of the data values that is within the 40 and the 160 here? All right, so Montserrat, how about other people? Yeah, so that means that it's going to be 99.9%, okay, of the data values that will be within those 2 values. That means that it's almost 100%, right? So that means that usually the other books don't talk about the last case, but this book talks about it. Okay, usually they just talk about the first 3 cases. Okay, all right, good, everyone. I'm gonna let you guys try another one. All right, so let's try this one. This is a different example. Let's say I'm going to give you this. So the mean is 80. And if you go to the left, 1 standard deviation of the mean, let's say the standard deviation in this case is 2, okay? What is the value right here, everyone? And what is the value on the right? And what is the value on the left? Can you type both of them for me? What is the value to the left of the 80? And then what's the value to the right of the 80? All right, Merlos, good, Uriel. Remember that. Oh, sorry, my bad. Hold on. This one should be the S sub x. Yeah, my bad. Sorry about that. S sub x. And then the mean is 80. Yeah. All right, so which is good now. All right, good. Uriel, Merlos, how about other people? I don't see other people trying. All right. So if you go to the left one, standard deviation, and that means that you just take the 80 minus 2, which is 78, right? And if you go to the right, that means that you take the 80 plus 2, which is 82, and that's it. Yes, that's it. Gabby, Evelyn, good. And what is the percent of this area, everyone? The percent that is between 78 and 82? What is the percent? If you look at the rule again, what is the percent? On the exam, they will ask you about these questions. All right, Uriel, Monserrat. The percent, like the rule, if you go to the left one, go to the right one, standard deviation, then what is the percent of that area? Yeah, it's going to be 68%, right? It's the first case, everyone. It's this case. See that? If you go to the left one, go to the right one, then the area will be 68, okay? Yeah, so it's 68%, okay? So everyone, if it's 68%, then what is the area of the tail here, everyone? Because they will ask you about that. What is the area of the left tail and what is the area of the right tail? What is the area of the left and the right? Let's talk about the left tail first. Do it separately. So what's your answer? Do you guys have an idea of what to do?
Like add it together with the 68%?
Like just the area of the left tail of this one, just this one.
Oh.
Yeah.
Okay.
What is it? Because on the exam, I'm sure they will ask some questions like this. All right, I got Uriel. How about other people? All right, we'll check to see if Uriel got it right, okay? So we represent the whole distribution by what percent, everyone? Can you type in the chat for me? The whole thing, the whole distribution by what percent? The whole thing by what percent? We always represent the whole by 100%, right? So the area of this entire distribution is 100%, right? So that means that to find the area of the left tail and the right tail, you just need to take 100% minus 68%, right? Which is what, everyone? What is 100 minus 68? Right. About other people? 32, right? 32%, okay? 32%. And this 32% is the area of both tails, okay? Left and right. So left and right, okay? So now, if you know that, then what is the area of the left tail, everyone? Type in the chat for me. All right, Uriel. Now we got 32%, which is the area of two tails. And then what is the area of the left tail? Right, Uriel, good. How about other people? Evelyn? How about other people? I want you guys to try it first. Because the left tail is the same as the right tail. Yes, Merlot's good. Therefore, you just have to divide 32% by 2, right? Which is 16%. Yeah, so the area of the left tail is 16%, okay? The area of the left tail is the same as the area of the right tail, okay? Then, what is the area of the right tail, everyone? Of the right tail. What is it, everyone? Type in the chat for me. What is the area of the right tail here? All right, good. Yeah, so it's the same as the left one, which is also 16%, right? It's half of 32. So it's also 16%, okay? All right, so that's how you do it. So in the future, I'm sure they will ask for some questions like this. They will ask you about the area in the middle, and then after that, they will ask you about the areas of the tails as well. So you need to know how to do it, okay? You need to know that we always represent the whole thing, like a whole work or a whole, like maybe a whole cake by 100%. You always represent a whole by 100%, okay?